Dario Amodei, former employee at OpenAI and current CEO and founder of Anthropic, has dropped a new essay in which he details his thoughts on DeepSeek, model innovation, and GPU export controls to China. This, combined with new evidence that shows DeepSeek may have actually distilled a lot of the data from OpenAI's models, is causing a stir in the AI industry. Let me break it all down. So here's his new essay, and it is incredible. Now, before we get to this, I want to show you a few of the rumors and possible evidence that DeepSeek actually stole data from OpenAI to create the R1 model. So first, in this Axios article, OpenAI says DeepSeek may have inappropriately used its model's output. Now, may have is not a strong statement. They're not saying definitely did, but at the same time, there was evidence in the fact that the DeepSeek R1 model itself says it was trained by OpenAI. Here's an example posted to the OpenAI subreddit right here. I was developed by OpenAI, a company founded in December 2015 by Sam Altman, Elon Musk, Greg Brockman, Ilya Sutskever, and so on. And so I've seen a few of these instances in which DeepSeek just says it was trained by OpenAI. Now, that doesn't necessarily make it true. Obviously, models hallucinate all the time, and there could be a number of reasons that DeepSeek R1 has said this, but it is interesting. Let me show you a couple of the things. Now, this is Jonathan Ross, CEO and founder of Groq. He specifically talks about how distillation works. And if you're not familiar with distillation, it is basically a small model learning from a big model. That is the most simplistic way to put it. Let's hear how Jonathan Ross explains what might have happened.
If there's a really good model already right here, just have it generate the data and you go whoop right up to where it is. And that's what they did. So it is true that they spent about 6 million or whatever it was on the training. They spent a lot more distilling or scraping the OpenAI model.
So a lot of the top people in the industry, and this is not just Anthropic leaders, OpenAI leaders, this is Groq's leader. And Groq is an inference provider, and they only work with open source models right now. So he is not incentivized in any way to say these things as far as I can tell. And so what he's basically saying, and what a lot of people are kind of triangulating around, is that, first of all, the $5 million number to train R1, maybe. But really, they spent a ton more before that, and I'm going to get to that. Apparently, they have 50,000 GPUs, but they spent a lot more in that in the research and development, and they also spent a lot more than that in the actual scraping of OpenAI's models. And so what a lot of people are saying is it is distilled down from an OpenAI model. Now, that isn't taking away some of the innovations that the DeepSeek team has made. And the DeepSeek team seems to be legit. They seem to be very smart and genuine with their efforts to push frontier AI. But I just want to put all of this in context for you and report on the new findings that I'm seeing around the web. Now here's David Sachs, AI and crypto czar for the United States, essentially saying the same thing. Let's watch.
There's a technique in AI called distillation, which you're going to hear a lot about. And it's when one model learns from another model. Effectively, what happens is that the student model asks the parent model a lot of questions, just like a human would learn. But AIs can do this, asking millions of questions, and they can essentially mimic the reasoning process that they learn from the parent model, and they can kind of suck the knowledge out of the parent model. And there's substantial evidence that what DeepSeek did here is they distilled the knowledge out of OpenAI's models. And I don't think OpenAI is very happy about this.
All right, so he is saying the same thing. Now, let's get to the main reason we're here today, Dario's essay. So Dario says, my thoughts on China, export controls, and two possible futures. And you could probably start to guess what two futures he's referencing are. Thanks to the sponsor of this segment, Recraft. Recraft is an image generation and editing tool. You've probably heard of it if you've watched this channel at all. Recraft's V3 model secures the #1 spot on the Hugging Face leaderboards, surpassing Midjourney and OpenAI's DALL-E with an impressive 1152 ELO rating. This is huge because Hugging Face is the leading platform for evaluating text-to-image models, so it has some stiff competition. But it was still #1. So why is Recraft so powerful? Well, it thinks in design language, giving you full control over your visuals, which is not something other models can say. Photorealistic images, posters, complex scenes, Recraft can do it all in a stunning way. And for realistic images, they are truly lifelike with high anatomical accuracy. Plus, Recraft has an easy to use API for developers to integrate its capabilities into your application. Recraft has over 3 million users already with companies like Netflix, Airbus, and Asana, and it's earned the trust of all of them. And here's the best part, of course, they worked with me to provide you with a great promo offer. Use the code BERMAN12 for $12 off any paid plan. Whether you start from the free version or go straight for unlimited access for $48 a month, there is a plan for everyone. So I'll drop the links in the description below. It's also right here. And then also here's the QR code, which you can just scan with your phone. So don't miss out, try Recraft today. And now back to the video. All right, so here's the article in a Google Doc so I can highlight it. And this article is about DeepSeek. It is about scaling laws. And through this article, he shows that actually what happened with R1 should have been expected. And the reaction of the markets dropping NVIDIA by 16% was a stunning overreaction. And by the way, I agree with that. That is insane that that happened, and really shows that a lot of analysts and investors truly do not understand what's going on in artificial intelligence. So he starts with, I won't focus on whether DeepSeek is or isn't a threat to US AI companies like Anthropic, although I do believe many of the claims about their threat to US AI leadership are greatly overstated. Okay, so right out of the gate saying, this whole thing was blown way out of proportion. But he does say export policies become even more existentially important than they were a week ago. Let me break that down for you. What do export controls actually do? What do they mean? Well, right now there are export controls which make it illegal to export cutting edge GPUs and AI chips to China. Now, the reason for that is we don't want China building out AI infrastructure that would eventually allow them to maybe reach AGI and ASI before that, because at that point, it's too late. Then we live in a unipolar world. China is the leader. And really, there's no catching up after that. And so these policies are put in place so China cannot get their hands on vast amounts of cutting edge GPUs, generally from NVIDIA, like the H100. But these export controls don't always work. At least there's some evidence that DeepSeek and China in general has some H100s, and they do that through shell companies. They do that through smuggling, kind of crazy stuff, to be honest. I'd love to cover that in more detail because it's interesting from a geopolitical standpoint. It's interesting from a technology standpoint. And yeah, it just sounds like a movie. Now he goes on to talk about the three dynamics of artificial intelligence. First, scaling laws. If you've watched this channel at all, you've heard me talk about this quite a bit. Now remember, Dario worked at OpenAI for a while before starting Anthropic. So Dario and his Anthropic co-founders were among the first to document the scaling laws back when he was working at OpenAI. All else equal, scaling up the training of AI systems leads to smoothly better results on a range of cognitive tasks across the board. Basically, every order of magnitude increase in the scale of a training run or the amount of compute you're throwing at something, the smooth linear increase in quality you're going to see. So he gives some numbers. $1 million model might solve 20% of important coding tasks. 10 million, so that's 10x, might solve 40%. 100 million, that's 100x, might solve 60%. So exponential increase in spend, linear increase in quality. That is one of the scaling laws. These differences tend to have huge implications in practice. Another factor of 10 may correspond to the difference between an undergraduate and PhD skill level, and thus companies are investing heavily in training these models. And that's the thing. They get exponentially more expensive to get these linear improvements. And so it really does take a crazy amount of money, a crazy amount of compute to actually squeeze out these improvements in quality. Next is the shifting curve. And here he talks about both on the software and architecture side and the hardware side, improvements that provide huge jumps in efficiency and quality. So for example, it could be an improvement to the architecture of the model, a tweak to the basic transformer architecture. New generations of hardware also have the same effect. And so what you're seeing is these improvements in efficiency, these innovations could result in a 1.2x improvement, a 2x, a 4x improvement. And so That is the shifting curve that he's referring to. Every frontier AI company regularly discovers many of these CMs. That's compute multipliers. Frequently small ones, 1.2x, sometimes medium ones, 2x, and every once in a while, very large ones, 10x. Now I want to read this slowly because this is critically important. Listen to this. Because the value of having a more intelligent system is so high, this shifting of the curve typically causes companies to spend more, not less, on training models. The gains in cost efficiency end up entirely devoted to training smarter models, limited only by the company's financial resources. So that is a mixture of Jevons paradox and just the nature of intelligence exploding right before our eyes. It's not that we're going to reach some plateau one day and companies are going to say, okay, we're done. No more training, no more inference needed. No, it's quite the opposite. Every time we have this huge unlock in terms of efficiency or cost reduction, all of the compute available continues to be used in full. It just goes towards whatever that next step up is. People are naturally attracted to the idea that first something is expensive, then it gets cheaper, as if AI is a single thing of constant quality. And when it gets cheaper, we'll use fewer chips to train it. That is so wrong. And that was the general understanding, I guess, of the broader market, the analysts, the investors. That is why NVIDIA dropped so much. And by the way, as I've said, they're so wrong about that. But what's important is the scaling curve. When it shifts, we simply traverse it faster because the value of what's at the end of the curve is so high. So again, when these things become cheaper, when these things become much more efficient, when they become faster, we don't use less of it, we use more because the value of intelligence is basically infinite. And obviously, whichever country reaches artificial superintelligence first is going to be the dominant country for essentially ever, I suppose. I don't really see an argument where once a country reaches ASI, anybody else can catch up. The only exception to that is if ASI can't be controlled, but that's a topic for another video. Now, he also just kind of quickly mentions, I guess the number today is maybe 4 times a year. So the improvement on these models, cost, efficiency, speed, is about 4x per year. And that's an important number to keep in mind as we bring it back to DeepSeek R1. Now, before we get to DeepSeek R1 and how it all ties together, let me show you this last dynamic of AI development. So this is called shifting the paradigm. Every once in a while, the underlying thing that is being scaled changes a bit, or a new type of scaling is added to the training process. So what does that actually mean? In 2024, the idea of using reinforcement learning to train models to generate chains of thought has become a new focus of scaling. This is test time compute. And remember, what is test time compute? That just basically means the models are able to think when you prompt it. It uses a lot more tokens, generates a lot of potential outputs, and then chooses the best one. Very oversimplification, but that's generally what it means. And so this was a new thing. In 2024, using reinforcement learning to train the models to think was a new thing. Anthropic, DeepSeek, and many other companies have found that this training greatly increases performance on certain select, objectively measurable tasks like math, coding competitions, and on reasoning that resembles these tasks. Now, why is that? If you remember back to AlphaGo, that was the AI system out of Google DeepMind that was able to beat every human Go player in the entire world. And really, it wasn't even close. What they discovered is, rather than giving the AlphaGo model a bunch of annotated games, annotated by humans, they can essentially just let the model play a bunch of games itself, find the games which it won, and then retrain on that and essentially just continue playing until it finds the most optimal strategies. And it was such a good method of training, they actually have this famous move number 37 in the game against Lee Sedol, who is the best Go player in the world. And essentially on move 37, AlphaGo made a move that every human analyst, every human Go player basically looked at it and said, I don't understand this at all. This was a mistake. But then towards the end of the game, that move ended up being the pivotal winning move way back. And it was such a novel idea in the game of Go and could only really be discovered through self-play, not by looking at games that have been played by humans, because no human had ever tried anything like that. That's the power of reinforcement learning. That's also why reinforcement learning is especially good at things like math, coding competitions, and reasoning, because typically there's a reward function that can be well defined. With math, there's an answer. With reasoning and logic, there's typically an answer. With coding, there's typically an answer. And so when that happens, there can be a really well-defined reward function that tells the model whether they got the output right or wrong. And that is what's really powerful about applying this kind of second layer of training to the models to allow them to do test time compute. So this new paradigm involves starting with the ordinary type of pre-trained models and then as a second stage using reinforcement learning to add the reasoning skills. Importantly, because this type of RL is new, we are still very early on the scaling curve, which is very exciting to hear because it is already so good. Now, a lot of people don't know, but DeepSeek released a model in December called DeepSeek V3. This was not a thinking model. This was just a base model and it performed really well. Now, what Dario is arguing is that, in fact, the DeepSeek V3 model was the real innovation. And he's not the only one to say that. Andrej Karpathy also pointed it out when it came out, and his post kind of went under the radar. I'll show you that in a moment. So DeepSeek V3 was actually the real innovation and what should have made people take notice a month ago. We certainly did. As a pre-trained model, it appears to come close to the performance of state-of-the-art US models on some important tasks while costing substantially less to train. So in the DeepSeek V3 model, they already had a really good cutting edge model that was much more efficient to train. That was before R1. And so what Dario is about to argue is that R1 is simply the second stage, the reinforcement learning stage applied to the V3 model. And the innovation actually happened in the V3 model. Now, as a quick reminder, here's that post by Andrej Karpathy back from December when DeepSeek V3 came out. DeepSeek, a Chinese AI company, making it look easy today with an open weights release of a frontier grade LLM trained on a joke of a budget. 2048 GPUs for 2 months, $6 million. So he already saw it and he also kind of compared to what it took to train other comparable models. Now, here's the thing. If these rumors are true, that DeepSeek basically just scraped data from OpenAI's cutting edge models and distilled it down into DeepSeek V3, then all of this kind of makes more sense. Now, here's the thing. I know a lot of you are thinking this right now. Well, didn't OpenAI essentially scrape the entire web for free and then they were able to build the model? What's the difference between them and DeepSeek scraping them and then distilling their own model? Well, I don't know. Nothing, I guess, right? I kind of agree with you there. I think this meme says it all. This is hilarious. So we have OpenAI fishing in a lake of real data, and then they use it to make ChatGPT. DeepSeek sneaking up behind, and all of a sudden, DeepSeek is fishing out of that bucket, which was trained from real data. So again, what's the difference? Nothing. But I guarantee going forward, OpenAI is going to be even more cautious about companies scraping their data and especially the reasoning, the chain of thought. That is most likely why they're not showing the chain of thought publicly. But maybe there are subtle ways to extract at least outlines of the chain of thought from the OpenAI models. Now back to Dario's essay. So what he's going to argue is that the $5 million number that has been floating around is not really accurate or taking in the context of everything that happened. So DeepSeek does not do for $6 million what cost US AI companies billions. I can only speak for Anthropic, but Claude 3.5 Sonnet is a mid-sized model that costs a few tens of millions to train. Also, 3.5 Sonnet was not trained in any way that involved a larger or more expensive model. That's critical. He's saying we did not distill it from another larger, better model. Thus, I think a fair statement is DeepSeek produced a model close to the performance of US models 7 to 10 months older for a good deal less cost, but not anywhere near the ratios people have suggested. So he's saying the frontier models from Anthropic, the frontier models from OpenAI, they're about 7 to 10 months ahead. So there was a tweet from an OpenAI employee. I'm actually struggling to find it right now, but it essentially said, "Congratulations to DeepSeek. They independently found innovations that we kind of found 8 months ago." So this whole timeline that DeepSeek is 8 months behind is starting to maybe make sense. And he says the same thing here. DeepSeek produced a model close to the performance of US models 7 to 10 months older for a good deal less cost. So that is essentially the consensus. But the cost is important. But Dario is arguing that the cost reduction is actually perfectly in line with expectations. If the historical trend of the cost curve decrease is 4 times per year, that means in the ordinary course of business, we'd expect a model 3 to 4 times cheaper than 3.5 Sonnet GPT-4o around now. So exactly what happened. All of this is to say that DeepSeek V3 is not a unique breakthrough or something that fundamentally changes the economics of LLMs. What's different this time is that the company that was first to demonstrate the expected cost reductions was Chinese. US companies will soon follow suit, and they won't do this by copying DeepSeek because they too are achieving the usual trend in cost reduction. Now, he goes on to explain why the $5 million number is misleading and why most of these frontier AI companies are actually spending a lot more than what it costs just to train that base model. So both DeepSeek and US AI companies have much more money and many more chips than they use to train their headline models. The extra chips are used for R&D to develop the ideas behind the model and sometimes to train larger models that are not yet ready. DeepSeek actually had, and this is something that's been reported, 50,000 Hopper generation chips, which I'd guess is within a factor of 2 to 3x of what the major US AI companies have. So Colossus by X.AI has 2 to 3x that. So those 50,000 chips cost $1 billion. Thus, DeepSeek's total spend as a company is not vastly different from US AI labs. That's an important thing to note. People freaked out over the $5 million number. Obviously, it's true if you don't look at the full context of what it took to actually reach that model and publishing that model. Now, again, there are innovations there, and he gives DeepSeek credit. They did find these innovations, and they did make the model much less expensive to train. And by open sourcing it, which you know I love, everybody benefits from it. All of the US AI companies are essentially going to take these techniques and apply them to the cutting edge models as well. Accelerate, accelerate, accelerate. The efficiency innovations DeepSeek developed will soon be applied to both US and Chinese labs to train multi-billion-dollar models. Again, we're not slowing down. We are not spending less on NVIDIA chips. We are doing the exact opposite, Jevons paradox. And now he gives his prediction for AI smarter than humans. Making AI that is smarter than almost all humans at almost all things will require millions of chips, tens of billions of dollars at least, and is most likely to happen in 2026, 2027. There is his prediction. All right, so then in 2026, 2027, what happens? Dario argues, this means that we could end up in one of 2 starkly different worlds. In the US, multiple companies will definitely have the required millions of chips to hit this AGI moment. The question is whether China will also be able to get millions of chips. If they can, we will be in a bipolar world. US and China will be the powerhouses. And in this time frame, that means this AI will be able to make massive, extremely rapid advances in science and technology. But even if the US and China were at parity with what their AI capabilities are, listen to this. It seems likely that China could direct more talent, capital, and focus to military applications of the technology. Combined with its large industrial base and military strategic advantages, this could help China take a commanding lead on the global stage, not just for AI, but for everything. If China can't get those millions of chips, let's go down that other path, we'll at least temporarily live in a unipolar world where the US and its allies have these models. Now, he goes on to talk about export controls and how important they are in making sure that the US and its allies stay in the lead. The performance of DeepSeek does not mean the export controls failed. They were not substantially more resource constrained, they being DeepSeek, than US AI companies, and the export controls were not the main factor causing them to innovate. They are simply very talented engineers and show why China is a serious competitor to the US. Now, if they have $1 billion in chips, he argues $1 billion of economic activity can be hidden, but it's hard to hide 100 billion or even 10 billion. And also, how do you smuggle that many chips in? How do you wrap corporate entities in shell companies and buy them and ship them in? This is not easy to do at that scale. Maybe 1 billion, but certainly not 10 and 100% not 100 billion. So that is his argument. We need tight export controls to maintain our lead in AI. Now, one last thing I want to point out, and this is the thing that I agree with so strongly. Incidentally, and this is a footnote, I think the release of the DeepSeek models is clearly not bad for NVIDIA, and that a double-digit 17% drop in their stock in reaction to this was baffling. Again, that's because A lot of the market just doesn't get where this thing is going. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.